Welcome! Today, we're diving into the fascinating world of data science. In our increasingly digital world, data is everywhere, from the apps we use to the transactions we make. But what exactly is data science? Simply put, it's the field that uses scientific methods, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Data science combines expertise from statistics, computer science, and domain knowledge to turn raw data into actionable information. In this video, we'll explore the core concepts, tools, and real-world applications of data science, helping you understand why it's such a vital field today. Let's get started by understanding the basics. Data science is more than just crunching numbers. It's an interdisciplinary field that blends mathematics, statistics, computer science, and domain expertise. The goal is to analyze large volumes of data to uncover patterns, trends, and relationships that can inform decisions. Whether it's predicting customer behavior, optimizing business processes, or powering artificial intelligence, data science is at the heart of modern innovation. By leveraging powerful tools and techniques, data scientists can transform raw data into meaningful insights that drive progress across industries. The data science process typically follows a series of steps. It starts with defining the problem you want to solve. Next, you collect and prepare the data, which often involves cleaning and organizing it. Then, you explore and analyze the data, looking for patterns or anomalies. After that, you build models using statistical or machine learning techniques. Finally, you interpret the results and communicate your findings to stakeholders. This process is iterative, meaning you might revisit earlier steps as new insights emerge or as you refine your approach. Data comes in many forms, and understanding these types is crucial for any data scientist. Structured data is organized in tables, like spreadsheets or databases, making it easy to analyze. Unstructured data, such as text, images, or videos, doesn't fit neatly into tables and requires specialized techniques to process. There's also semi-structured data, like JSON or XML files, which have some organizational properties but aren't as rigid as structured data. Recognizing the type of data you're working with helps determine the best tools and methods for analysis. To succeed in data science, certain skills are essential. First, a strong foundation in mathematics and statistics is necessary for analyzing data and building models. Programming skills, especially in languages like Python or R, are also vital for handling data and implementing algorithms. Data scientists need to be comfortable with data visualization tools to communicate findings clearly. Additionally, domain knowledge helps in understanding the context and making sense of the data. Finally, critical thinking and problem-solving abilities are crucial for navigating complex data challenges. Collecting data is a foundational step in data science. Data can be gathered from various sources, such as databases, online APIs, surveys, sensors, or even social media platforms. The method you choose depends on the problem you're solving and the type of data you need. Sometimes, data is already available in public datasets, while other times, you may need to design experiments or conduct interviews to gather new information. Ensuring data quality and relevance is key to successful analysis. Once data is collected, it often needs cleaning and preparation before analysis. This involves handling missing values, correcting errors, and transforming data into a usable format. Data cleaning is crucial because poor quality data can lead to misleading results. Techniques like removing duplicates, standardizing formats, and dealing with outliers help ensure the data is accurate and consistent. This step can be time-consuming, but is essential for building reliable models and drawing valid conclusions. Exploratory data analysis, or EDA, is the process of examining datasets to summarize their main characteristics. This step involves using statistical graphics and visualization tools to spot trends, patterns, and anomalies. EDA helps data scientists understand the data's structure and relationships, guiding further analysis and model building. Common techniques include plotting histograms, scatter plots, and box plots, as well as calculating summary statistics like mean, median, and standard deviation. Statistical analysis is at the core of data science. It involves applying mathematical techniques to interpret data and draw conclusions. Descriptive statistics summarize data, while inferential statistics help make predictions or test hypotheses. Data scientists use statistical tests to determine if observed patterns are significant or just due to chance. Mastery of statistics enables data scientists to build robust models and make informed decisions based on data. Machine learning is a key component of data science. It refers to algorithms that allow computers to learn from data and make predictions or decisions without being explicitly programmed. There are various types of machine learning, including supervised, unsupervised, and reinforcement learning. By training models on historical data, data scientists can forecast future trends, classify information, or even recognize patterns in images and text. Supervised learning is a machine learning approach where the model is trained on labeled data. This means the input data comes with known outcomes, allowing the model to learn the relationship between inputs and outputs. Common applications include classification, such as spam detection, and regression, like predicting house prices. Supervised learning is widely used because it provides clear feedback during training, making it easier to evaluate model performance. Unsupervised learning deals with data that doesn't have labeled outcomes. The goal is to find hidden patterns or groupings within the data. Clustering is a common technique, where similar data points are grouped together. Dimensionality reduction is another, simplifying data while retaining important information. Unsupervised learning is useful for discovering structure in data, such as customer segments or underlying themes in text documents. Reinforcement learning is a unique branch of machine learning where an agent learns to make decisions by interacting with an environment. The agent receives feedback in the form of rewards or penalties, gradually improving its strategy over time. This approach is commonly used in robotics, game playing, and autonomous systems. Reinforcement learning is powerful for solving complex problems where the best action isn't always obvious and must be discovered through trial and error. Big data refers to extremely large and complex datasets that traditional processing tools can't handle efficiently. In data science, big data technologies like Hadoop and Spark are used to store, process, and analyze vast amounts of information. These tools enable data scientists to work with data from sources like social media, sensors, and transaction records, uncovering insights that would be impossible with smaller datasets. Data visualization is the art and science of presenting data in graphical or pictorial form. Effective visualizations help people understand complex data quickly and clearly. Tools like charts, graphs, and dashboards are commonly used to highlight trends, compare values, and communicate findings. Data visualization is a crucial skill for data scientists, as it bridges the gap between raw data and actionable insights. Data scientists use a variety of tools to analyze and visualize data. Popular programming languages include Python and R, both known for their powerful data analysis libraries. Tools like Jupyter Notebook and RStudio provide interactive environments for coding and visualization. For big data, platforms like Hadoop and Spark are essential. Data visualization tools such as Tableau and Power BI help turn data into compelling stories. Artificial intelligence, or AI, plays a significant role in data science. AI systems can process vast amounts of data, recognize patterns, and make decisions with minimal human intervention. Machine learning, a subset of AI, is often used to build predictive models and automate tasks. As AI technology advances, data science is becoming even more powerful, enabling new applications in healthcare, finance, and beyond. Data science is transforming the business world. Companies use data science to optimize operations, improve customer experiences, and drive innovation. For example, retailers analyze purchase data to recommend products, while banks use predictive models to detect fraud. Data-driven decision-making helps businesses stay competitive and adapt to changing markets. In healthcare, data science is revolutionizing patient care and medical research. By analyzing patient records, genetic data, and clinical trials, data scientists can identify disease patterns, predict outbreaks, and personalize treatments. Machine learning models help diagnose conditions faster and more accurately, leading to better outcomes for patients. The finance industry relies heavily on data science for risk assessment, fraud detection, and investment strategies. Data scientists analyze market trends, customer transactions, and economic indicators to make informed decisions. Predictive models help banks and investment firms manage risks and identify new opportunities in a fast-paced market. Marketing teams use data science to understand customer behavior, segment audiences, and optimize campaigns. By analyzing data from websites, social media, and sales, marketers can tailor messages and offers to specific groups. This targeted approach increases engagement and maximizes return on investment. Transportation companies leverage data science to optimize routes, reduce costs, and improve safety. By analyzing traffic patterns, vehicle performance, and weather data, they can make real-time decisions that enhance efficiency. Predictive analytics also helps in maintenance scheduling and accident prevention. Sports teams and organizations use data science to gain a competitive edge. By analyzing player performance, injury data, and game statistics, coaches can make better decisions about training and strategy. Fans also benefit from data-driven insights, such as personalized content and enhanced viewing experiences. Education is another field benefiting from data science. Schools and universities analyze student performance data to identify learning gaps and personalize instruction. Predictive analytics can help educators intervene early with at-risk students, improving outcomes and supporting student success. Ethical considerations are crucial in data science. Data scientists must ensure privacy, fairness, and transparency in their work. This means protecting sensitive information, avoiding biased algorithms, and clearly communicating how data is used. Responsible data science builds trust and ensures that technology benefits everyone. Despite its potential, data science faces several challenges. Data quality and availability can limit analysis, while privacy concerns require careful handling of sensitive information. Interpreting complex models and ensuring they are free from bias is also difficult. Overcoming these challenges requires technical expertise, ethical awareness, and ongoing learning. A data scientist wears many hats. They collect and clean data, perform analysis, build models, and communicate results. Collaboration is key, as data scientists often work with business leaders, engineers, and other stakeholders. The role requires a blend of technical skills, creativity, and business acumen to solve real-world problems. While both data analysts and data scientists work with data, their roles differ. Data analysts focus on interpreting existing data and generating reports, often using descriptive statistics and visualization tools. Data scientists, on the other hand, build predictive models and develop algorithms to solve complex problems. Both roles are important, but data scientists typically require deeper technical and programming skills. Data science relies on a variety of algorithms to analyze data and make predictions. Some common algorithms include linear regression for predicting values, decision trees for classification, and clustering algorithms like k-means for grouping data. Understanding when and how to use these algorithms is a key part of a data scientist toolkit. Feature engineering is the process of selecting and transforming variables in your data to improve model performance. This might involve creating new features from existing data, scaling values, or encoding categorical variables. Effective feature engineering can significantly boost the accuracy and usefulness of predictive models. Evaluating models is a critical step in data science. Common metrics include accuracy, precision, recall, and F1 score for classification tasks, or mean squared error for regression. Cross-validation techniques help ensure models generalize well to new data. Proper evaluation prevents overfitting and ensures reliable predictions. Once a model is built and evaluated, it needs to be deployed into production. This means integrating the model into business systems or applications so it can make real-time predictions. Deployment involves considerations like scalability, monitoring, and updating models as new data becomes available. Successful deployment ensures that data science delivers ongoing value. The field of data science is constantly evolving. New algorithms, tools, and best practices emerge regularly. Data scientists must stay up to date by learning new skills, attending conferences, and participating in online communities. Lifelong learning is essential for staying relevant and effective in this dynamic field. Open data initiatives encourage organizations to share datasets with the public, fostering collaboration and innovation. Data scientists can use open data to develop new solutions, validate findings, or contribute to community projects. Collaboration across industries and disciplines accelerates progress and leads to better outcomes for society. Cloud computing has revolutionized data science by providing scalable storage and processing power. Platforms like AWS, Google Cloud, and Azure allow data scientists to work with massive datasets and deploy models globally. Cloud services also enable collaboration and streamline workflows, making data science more accessible and efficient. The Internet of Things, or IoT, connects everyday devices to the internet, generating vast amounts of data. Data science helps make sense of this information, enabling smart homes, predictive maintenance, and real-time monitoring. IoT and data science together are driving innovation in industries from manufacturing to healthcare. Natural language processing, or NLP, is a branch of data science focused on understanding and generating human language. NLP powers applications like chatbots, language translation, and sentiment analysis. By analyzing text data, data scientists can extract meaning, detect emotions, and automate communication tasks. Computer vision is another exciting area of data science. It involves teaching computers to interpret and understand visual information from images or videos. Applications include facial recognition, medical imaging, and autonomous vehicles. Computer vision combines machine learning with image processing to unlock new possibilities. Time series analysis is used to analyze data points collected or recorded at specific time intervals. This technique is crucial for forecasting trends, such as stock prices, weather patterns, or sales figures. Data scientists use specialized models to identify patterns and make predictions based on historical data. Anomaly detection is the process of identifying unusual patterns or outliers in data. This is important for applications like fraud detection, network security, and quality control. Data scientists use statistical and machine learning techniques to spot anomalies and alert organizations to potential issues. Recommendation systems are widely used in e-commerce and entertainment platforms. By analyzing user behavior and preferences, these systems suggest products, movies, or music tailored to individual tastes. Data science powers these algorithms, enhancing user experience and driving engagement. The future of data science is bright and full of possibilities. As technology advances, data science will continue to drive innovation in every industry. Emerging fields like quantum computing, edge AI, and automated machine learning are set to transform how we collect, analyze, and use data. Staying curious and adaptable will be key for anyone looking to thrive in this exciting field. If you're interested in learning data science, there are many resources available. Online courses, textbooks, and tutorials can help you build foundational skills. Participating in data science competitions or joining online communities is a great way to gain practical experience and connect with others in the field. Remember, persistence and curiosity are your best allies on this journey. To sum up, data science is a dynamic and interdisciplinary field that transforms raw data into valuable insights. It combines skills from mathematics, statistics, computer science, and domain expertise to solve real-world problems. From business and healthcare to entertainment and beyond, data science is shaping the future. Embracing data science means embracing a world of possibilities. At its core, data science is the discipline of extracting knowledge and insights from data using scientific methods, algorithms, and systems. It merges expertise from statistics, computer science, and domain knowledge to analyze both structured and unstructured data. Data science empowers organizations and individuals to make data-driven decisions, solve complex problems, and innovate across industries.